Hi, my name is Dr. Jeffrey Escobar. I'm the Senior Manager for Swine Nutrition Research at Novus International. And today we'll be briefly talking about how can we apply some concepts on nutrient digestibility to reduce feed costs and maintain productivity in pigs. The outline for the presentation is we're going to go through some basic concepts of what is digestibility, how do we measure it, where do we measure it, how do we calculate the digestibility coefficients that appear on tables, and then basically how we use this technology to reduce feed costs and to help the bottom line of producers. So if we start with the first question, what is digestibility? It's basically the portion of nutrients that the enzymes of the animal is able to break down, and those nutrients are able to be absorbed by the animal. So that's basically what digestibility is. It's kind of a two-tiered type of component. How is digestibility measured? Since measuring what's actually absorbed by the animal and distributed around the body, it's difficult. We have taken a different approach, and basically what we do is we measure the amount of nutrients that are consumed by the animal, and we measure the amount of nutrients that are excreted by the animal, and by difference we can calculate digestibility. So where do we measure digestibility? It really depends on what nutrient are we interested on. We have two main points that we can talk about. At the end of the small intestine or at the end of the ileum, and then basically we'll be measuring nutrients in the digesta, and then we use this particular approach for amino acids. Why do we do it? Because then amino acids, once they go into the large intestine, into the cecum, then they are transformed by bacteria into other types of products, and it's harder to measure them. However, if we're talking about, for example, about minerals, then we can use measure digestibility at the end of the total tract, and we can use feces, and we don't have to use, in this case, surgically modified animals. So where do we measure digestibility? It really depends on the nutrient that we're interested in. That also we need to pay close attention when we talk about digestibility. Is it ileal digestibility? Is it total tract digestibility? Because the numbers and the coefficients and the meaning will change a little bit. So how we calculate digestibility coefficients? This is my diagram of a pig. So say if we feed 20 grams of lysine, and these 20 grams of lysine, for example, could be in soybean meal. So if we're just going to feed pure soybean meal that contains 20 grams of lysine. And at the end of the ileum, we take out the digestive samples and we measure and we calculate that there's 3 grams of lysine. So by difference, if we just know how much the animal consumed minus what's excreted, we can calculate a digestibility coefficient. And in this particular example, the number will be 85%. If we talk about basically one of our products, which is Cibenza DP100, it's a protease, and I'm going to talk about this product because we've been using these digestibility concepts on enzyme technology. So it's a protease that comes from Bacillus laciniformis. It's a stable product, so it can go through the pelleting process without worrying too much about it. With these supplemental enzyme, it's going to complement the endogenous enzymes, or the enzymes that the pig already has in itself. And it's going to contribute to hydrolyzed proteins that are already present in the feed. And if all this is true, what we're going to end up with an increase in the digestibility of protein and amino acids. And by increasing digestibility, we're delivering more nutrients to the animal, and we're putting less nutrients that are excreted from the animal. In this particular example, I'm going to talk about soybean meal. We've been doing this type of studies with soybean meal, wheat, meat and bone meal, and a lot of other kind of ingredients, but I'm just going to take soybean meal as an example. In this case, in the white bars, we can see a control sample of soybean meal. The black bars represent the same batch of soybean meal, so basically the exact same soybean meal with the addition of DP100, which is the protease. We can see in here we have the list of amino acids, and here we have the digestibility coefficient. The blue stars basically represents a significant increase in digestibility coefficients for just about all the amino acids. And if we average all the essential amino acids together, we can see that we have about a 5.8% points in digestibility. So this is important to know. We're talking about here percent points in terms of digestibility. The bottom line here is that what the protease is doing, it's increasing the amount of nutrients that are taken out of soybean meal, and they're putting them into the animal rather than being excreted. So by knowing this, we can rethink a little bit how can we use digestibility approach to basically reduce the cost of diets. So if we have a lysine content of 2.96% in soybean meal, for example, with a digestibility coefficient that you can obtain from a table, it says in this case, for example, 89%. So you can calculate by multiplying these two numbers, you can calculate that the digestible portion in this case will be 2.63%. Okay, and we can graph that here. The rest, which is the difference between the digestible and the total, it's what we're going to call the undigestible fraction, and that's the fraction that is going to be excreted out of the animal. So in this case, with a controlled, untreated soybean meal sample, we have the part that is digestible and the part that is undigestible. If we use the enzyme, if we use DP100, we know that we're going to get an increase in, let's say, 3.7 percentage points in digestibility. So that means that instead of 89%, our indigestibility coefficient will be 92.7%. So now if we take 92.7 and multiply by 296, we're going to get a new fraction that is digestible. And it's going to look something like this. This is the portion of digestibility that the animal will do. So this is what the pig will do, and it's still the same. This extra fraction of digestibility here is going to come by the action of the enzyme. By default, we're going to have less protein or less lysine that is undigestible and is less going to be excreted. If we look at it in the graphical portion of here, what the protease will do is we'll take from the undigestible portion, it will increase the digestibility, and then we have more nutrients that are now going to be into the digestible fraction, and less lysine is going to be excreted out of the animals. So bottom line, we're delivering more nutrition and more nutrients to the animal, and less is being excreted. So this would be our bottom line here. Higher protein amino acid digestibility is going to translate into lower feed costs, because by extracting more nutrients out of the feed, you're going to need less supplemental amino acids in the rations of the pigs. So let's look quickly at results that we have gotten from finishing animals studies. In this case, we have a positive diet that is corn soy diet, just pure corn soy diet. And then we have a diet that we call alternative. An alternative is pretty much anything that is not corn soy. And in this case, the diets were wheat and distillers based diet with almost no soybean meal. And then when we formulate the diets to be equal in nutrient content, what we observe is we observe a reduction in performance. And in this case, we're looking at hard carcass weight. And I like to look at hard carcass weight because that's how producers get paid nowadays. So despite our best nutrition efforts, we see a little bit of a reduction of performance. When we include the enzyme, in this case, we basically are able to recover the productivity or the production rate compared to alternative diet. This diet is considerably less expensive than this diet, but it will give you less carcass. This diet also, which is basically the same diet with the addition of the enzymes, will still be less expensive than the corn soy diet, and it's delivering the same amount of performance out of the animals. So basically you have lower feed costs without any sacrifice in productivity. You're going to end up with higher profitability. In this particular study, we also find out that we have an increase in dressing percent. And then the difference here between the black and the gray is another thing that we see typically when we start using a lot of alternative ingredients that are particularly high in fiber content. We see a reduction in the dressing percent, and we can recover that by the addition of the enzymes. In this other study, also with finishing pigs, we see the same case. In this case, a typical diet is a corn soy diet, and then we have an alternative diet. Again, this is a wheat with distillers diet, and then we see a reduction in the performance. This is the average daily gain of animals. And then when we add the enzymes, we are able to recover the growth performance of these animals. And then we get a tendency for the typical diet. So if we formulate diets correctly, there's even opportunity in pure corn soy diets to get more nutrients out of there. When we put together and then we see the main effect of the Cibenza enzymes, we can see that during the last two phases of the finishing of the animals, or the last 42 days for this particular study, we can see that there's an overall increase of about 6.3% increase in average daily gain. This translates into hot carcass weight, which is again how producers are paid nowadays. So like we saw in the first study, when we move from a corn soy diet to a diet that contains alternative ingredients, particularly high in fiber like wheat and distillers, really high nutrition level of distillers, we see a reduction in performance, and then when we add these Cibenza enzymes, we're able to recover that loss of performance. So again, basically having the same level of productivity at a lower feed cost rate. And then if we put together, basically, this is what the combined effect of these 4 treatments you have a clear picture here of what the effect of this Cibenza treatment is going to be, and you're going to get higher carcass gain. And this is about a 1.8% increase in hot carcass weight. So in summary, we know that Cibenza DP100 is a protease that increases protein and amino acid digestibility. By doing that, we're going to have less protein rich in the large intestine, and less protein is going to be available for fermentation. Fermentation produces ammonia. If we reduce fermentation, we're going to reduce ammonia production. If we reduce ammonia production, we're going to have a reduction in the pH of the gut, and the gut environment is going to be better for the animal. Overall, we're going to have an improvement in the gut health of the animal, and we all know that every time we improve the gut health environment of the pigs, you're going to get better feed efficiency, you're going to get better growth, and you're going to get better extraction of nutrients. And then we also have a reduction in nitrogen excretion, because more nitrogen is getting into the animal. So in conclusion, we can say that dietary supplementation with Cibenza enzymes is a viable solution to reduce feed costs while maintaining the level of productivity of the animals. And with that, I thank you for your attention.